Number 44. Find the length of the arc of a circle of radius 5 inches subtended by the central angle of 220 degrees. Alrighty. So what are they asking us to do? They're asking us to find the arc length. So pretend you have a circle. Okay. And I'm going to draw my vertical and horizontal axes. So they're giving us an angle in terms of degrees. So what I'm going to do is I'm first going to plot this in terms of degrees. So this is 0 degrees, this is 90 degrees, this is 180 degrees, and that's 270, right? We know, we work from positive x and then we rotate around counterclockwise. So an angle of 220 degrees would then be something that looks, I don't know, maybe like, let me see, like this, right? If we were to rotate 90, 180 to maybe 20. Something like that, right? So this angle right here is 220 degrees. Okay, 220 degrees. And what they're asking us to do is to solve for and find this arc length. The length of this arc. Okay, that's what they're asking us to do. So it turns out that there is a relationship between arc length S and the central angle, okay, theta, and the radius of the circle. Okay, so the radius of the circle could be this length, could be that length. They're both the same, right? So they told us the radius here is about 5 inches, so that's great. So it looks like we can just plug it in, but you got to be careful. The angle here has to be in terms of radians. Okay, radians. So what we first need to do is actually convert the 220 degrees into radians. Right, how do we do that? Well, we have a whole bunch of problems here in this chapter about how to do that. I'm going to run through it here. So this is 220 degrees multiplied then by, we're going to have degrees on the bottom, radians up on top, and we know that for every single pi every pi radians, there's 180 degrees. Right? We've seen this now conversion a bunch of times. So this simply now is going to work out. We can reduce this, right? This will be 22, and that's 18, and then we can even reduce it further right from there. We can reduce this by 2, so that's 11, and that's going to be 9. So this works on down to now simply 11 pi all over 9 radians. All right, that is now the central angle in radians. So what you can now do is we can now use this formula to solve for our arc length. So the angle here has to be in radians, and that was the point of what we just did. We found the radian measure. Okay, and then multiply it by the radius, and the radius here was 5 inches. So now all you have to do is just multiply it on out. The exact answer here will be 55 pi over 9 inches, excuse me. That's the exact answer. But what does that mean in terms of a number? We'll take out the calculator, do 5.5 multiplied by pi, which is about 3.14, and then divide it by 9. So that works out to be about, what do we get? That works out to be about 19.2. inches. So if you were to take this particular arc length, pretend you took a string and you measured it like that, and then you took the string, you brought it over here, and you took that piece and you straightened it out, the measurement of that length would be 19.2 inches. Guys, thanks so very much for tuning in. I appreciate that. Please help us out by subscribing and liking if you can. And we got a whole bunch of other problems out there, thousands of solved solutions just for you. All right, we'll see you in the next problem. Take care.